Welcome to the final exam, question number 45. It says that the calculations for the design of a column footing show that the footing is overstressed in shear. How would the design be changed? Alright, so you have a column footing. Here's your column, and it comes down into a footing. And it says overstressed in shear. How would it be changed? And I'll go ahead and do the quick answer to this. Quick answer is you need to increase the footing. You need to take this down because that's how it looks at it. It looks at, maybe you don't know, but this is the soil pressure. The way I like to think about it is everything's coming down right here. Your loads are coming down, and it's assumed that they're spread evenly over this footing for the most part, unless you have eccentric loads or a moment. Moment being like that. When I say eccentric loading, that means for some reason it's not loaded down the center of the column. It's loaded for some reason. Let's say you have like a corbel and it's coming out. And this is just an idea, and obviously you're probably never going to have this type of situation, but your entire load, or a big part of your load, is coming in on this beam. So therefore, that would be eccentric load. Here's the center line of the column. That's eccentric. What you could do is you could turn that into a moment. But anyways, we don't have that. We do not have that type of situation, so it comes straight down. Most of the time it will happen like this, and then you assume the soil is pushing back on it, evenly distributed. So you're going to have shear, and it has to make sure that this footing is thick enough to deal with it. And typically you won't put. You have question 44 that we just did last time had this shear reinforcing, which is known as stirrups. So if you look at, let's assume that this is here's a plan view. It's a square footing from plan. Here's the column coming in. Obviously, I'm just making this up. Here's the column coming in, and it's a square footing. And we're not going to have stirrups like we did. Like this could be a stirrup, and we don't. We'll have longitudinal reinforcing, and we'll have, well, it depends which way you're looking at it. Longitudinal, you'll have top and bottom reinforcing in reality, but you will not have these stirrups. You won't do stirrups, so you won't have these stirrup looking things like you did on the beam we had on question 44. That's not typically the case. You could put those in if you have certain case that made that necessary. But typically you won't. What you do is you increase the footing depth. So I think that's clear enough, and we've gone over this problem before. I think we've seen this problem 3 times now. So let's see what our answers are, and it should be increased thickness of footing. And remember, this reinforcing going across here is going to work with moment. This load from that resistance from the soil is going to make this usually will be in like kips per square foot or pounds per square foot, actually probably more like pounds per square foot, and it will be going up. So you have to design your footing to resist this type of movement on the footing. So you'll need, this will be in compression, this will be in tension, you'll need reinforcing to help it right there, and typically you'll put in top reinforcing as well. Alright, and there could be certain circumstances where you would need, for instance, if you had a little bit of a void right here and you have all the soil on top, you could use that top reinforcing as well. Alright, so let's go ahead and look at the answers. The footing should be made larger in plan. It says the calculations for design of a column footing show that the footing is overstressed in shear. how should the design be changed? And in the case of when you have this column, well, the square footing, it undergoes two-way shear. Two-way shear will go like this, and this dimension is d/2 right here. d/2. Alright, so in that case, in two-way shear, as you can see, it doesn't matter. This is the depth of the slab. It doesn't matter how big you get, your depth is still the same. If you go out here, you still have d/2. It doesn't move. So that's not going to help you for A. One-way shear. If you have one-way shear, if you take a look at it, and this is, you look at, so two-way shear, you look at this, kind of this is your issue. So it's not going to help. If you look at one-way shear, let's change colors back to blue. It's the depth is right here, that distance. So I guess it would go to here, so that would help you. But the best thing to do is, once again, increase your D. That's going to be the most realistic thing and the most efficient way to go about it. Alright, let's see what B is. B is the amount of reinforcing steel should be increased, and that's not going to do a thing. Realistically, if you had shear stirrups, then sure, that would help, but typically a foundation, spread footing type foundation will not, or a column footing will not have shear reinforcing, so we'll assume that's a no. And increasing your horizontal, let's call it horizontal reinforcing like that, is only going to help you on moment. It's not going to help you on shear. It's not designed to help you on shear, let's say that. Alright, C, stirrups should be provided. Once again, there could be, I'm not going to say that's a wrong answer, it's just not the best answer. And D, the thickness of the footing should be increased. That is the best answer. Alright, I will see you on question number 46.